We're going to discuss now the effect of damage and flooding. If the watertight integrity of a vessel is breached, i.e. if there's a hole put in the vessel below the waterline, we say that it's bilged, that the vessel is bilged. And what happens is that the buoyancy that we have in that compartment that's been bilged is lost. Therefore we have to regain the buoyancy, which means that our draft will change, so we'll lie deeper in the water to regain the lost buoyancy. So the draft will change and the metacentre will change, but the weight of the vessel will not change. Therefore the kg, the centre of gravity g, will remain in the same position. And that's because, according to Archimedes, we have to displace our own weight in water, and the underwater volume that we're displacing doesn't change because the water is actually going into the compartment. We're not actually pushing it out to one side. So our underwater volume doesn't change, although the draft changes. Because the underwater volume doesn't change, the weight of the vessel doesn't change, and the centre of gravity stays in the same position. And on this sketch here we can see that we're saying that this particular compartment has been bilged. Therefore we've lost this volume of buoyancy, and we regain it by going from waterline 1 to waterline 2. In effect, volumes y and z replace volume v. And let's have a look at an example to work through. So here's a barge, 90 metres long, 30 metres breadth, at a draft of 4 metres. And in the middle there is a compartment 20 metres long that gets bilged. So this compartment, the buoyancy in it is lost. 20 by 30 by 4, 2,400 metres cubed of buoyancy is lost. We need to regain that. So the formula that we use is to get this sinkage to regain the buoyancy is the lost volume of buoyancy divided by our intact waterplane area. Because the waterplane area has been breached here at the waterline, our intact waterplane area will be that amount plus that amount. So that's 30 plus 30 will be our intact waterplane area. So that's 35 plus 35 times 30, which is the breadth, which gives us 2,100 metres squared. So our intact waterplane is 2,100 metres squared. We divide the lost volume by the intact waterplane area, and it gives us a sinkage of 1.143 metres. Therefore our new draft is going to be 5.143 metres. So that's the first part that we had to calculate in this problem. So it's a quite straightforward formula. Lost volume over intact waterplane area gives us sinkage. Add that to our original draft, and that's our new draft. We're also asked to calculate the effect on the GM of the vessel. Okay, well, GM, as we know, is km minus kg. We haven't been given the kg, of course, which wouldn't change. But if we can work out our new km and compare it to our original km, then the difference is basically what the difference would be in the GM. So km is kb plus bm. kb is simply the draft divided by 2. So our old kb was simply 4 divided by 2, and our new kb is 5.143 divided by 2. Now we need to find our bm. Well, the original bm, before we were breached, we can use the simple formula b squared over 12d. 30 squared over 12 times 4, old bm 18.75. Therefore our old km will be the kb plus bm, 20.75. So if we can now find our new bm, add it to the new kb, and we can make the comparison. What changes now is that we cannot use b squared over 12d to work out the bm, because the waterplane area has been breached. Therefore we have to use the formula lb cubed over 12v. This is the same formula, just broken down because we can do that with an intact vessel. LB cubed over 12V. V represents the underwater volume. The underwater volume does not change because the weight of the vessel doesn't change. Therefore, underwater volume is simply 90 times 30 times 4. You notice we use the draft of 4 metres, 90 by 30 by 4. Length now, it was 90. 20 metres has gone because we've been bilged, so it's now 70. Breadth, of course, remains the same, so it's 70 by 30 cubed. So the new BM, 14.58. Add that to the new KB, 2.571, it tells us that our new KM is 17.151. Our old KM, as we looked before, was 20.75. So we've actually lost 3.599 metres. So we could say that the bilged vessel experiences a loss of GM of 3.599 metres due to the lowering, obviously, of the metacentre. So remember, the displacement doesn't change. Therefore, when you use this formula, LB cubed over 12V, the volume cannot change either.